Section 3.5, as promised, isotopes. So this section is talking about isotopes and atomic mass. First of all, isotopes, the name iso means same, and topes placement. So they are atoms of the same element. They're placed on the same box there on the periodic table. But what's different is that they have different mass numbers. They do have the same number of protons. Well, of course they do, because they're in the same spot, but they're going to have different number of neutrons. So here's an example. Let's look at the atomic symbols for isotopes of magnesium. First of all, we know this element is magnesium because we have the smaller number here, the 12, is the proton number. You look on the periodic table, and number 12 is magnesium. So we know these are isotopes of magnesium. Why? Because each of these has 12 protons. So it's magnesium, but it has different mass numbers. So that means they are different isotopes. So for example, on table 3.7 talks about isotopes of magnesium, and it shows that, okay, yes, magnesium, because it's magnesium, it has 12 protons. 12, 12, 12. And because protons are positive, and we know our atoms have an overall charge of 0, then the number of electrons, of course, are going to be 12, 12, 12 for these different isotopes. So what is different? The mass number, meaning protons plus neutrons. So to find the number of neutrons, we have 24 minus 12 to give us 12. For magnesium 25, we have 25 minus 12 gives us 13. For magnesium 26, we have 26 minus 12, which is 14, are the number of neutrons. All right, so naturally occurring carbon consists of 3 isotopes: carbon 12, carbon 13, and carbon 14. State the number of protons, neutrons, and electrons in each of the following. Well, rather than pressing pause, let's just do this together. Carbon is carbon, and so when you look over at the periodic table for carbon, the smaller number for carbon there is 6. So that means you have 6 protons for carbon, and you may go, why isn't there a 6 here? Well, when there's only one number, that designates what particular isotope it is. They assume you know, okay, if it's carbon, you go look on the periodic table to find how many protons there are. So carbon, when you look at the periodic table, there's 6 for the smaller number. So we have a 6 for the protons. This is another isotope of carbon, meaning it has the same number of protons. So it's 6. And carbon 14 has 6 protons. Now, to remember and to remind you, for an atom, atoms are neutral, so however many protons there are, 6 in this case, you're going to have 6 electrons for all 3 different isotopes. So what's different? Well, our mass number, i.e. the number of neutrons. So 12, take away 6 protons, gives us 6 neutrons. In this isotope, 13 minus 6 protons gives us 7 neutrons. And in this one, 14 minus 6 gives us 8 neutrons. As you can see, there we go. So now then that we could do it forwards, let's do it backwards. Write the atomic symbols for atoms with the following subatomic particles. All right? Let's first start with 8 protons. Well, we don't need to go any further. We look at the periodic table for something with the proton number of 8, and that is oxygen. So we know that oxygen is where we're going to start, so we write an O. Now then, because it has 8 neutrons, then we know that the mass number is going to be neutrons plus protons, so 8 plus 8, i.e. 16. All right. Now then, let's go to B. Something with 17 protons. When we look there, only thing with 17 protons is an isotope of chlorine, so it's chlorine. Now, because it says there's 20 neutrons, we have to add 17 plus 20 to get 37 for the mass number. Now C, 47. We look on our periodic table, and that's silver. Now then, we then have to add our proton number plus our neutron number. So 47 plus 60 is 107 to get the mass number. And so you will notice that we do it on our next slide here, that we can do it that way, or technically we could have just had 16 next to the O, 37 next to the chlorine, 107 next to silver, because the 8 on O, the 17 on Cl, and the 47 on silver on Ag is understood. All right, so let's look at this. Which of the pairs are isotopes of the same element? Press pause, see if you can do this. All right, so you're back. We know that isotopes have to have the same proton number, and proton number is the smaller number of the two. Well, the 8 and the 7, not the same, so they're not isotopes. Right here on B, we have 6 and 6, so these are isotopes. Now, question 2. In which of the pairs do both atoms have 8 neutrons? Well, we know that we're going to subtract the mass number and subtract the proton number from it. So that's 7, so right then and there, that we don't need to do any more math because it's not A. B, we have 12 minus 6, well, that's not 8. C, 15 minus 7 is 8, well, okay, it might be this one. Well, 16 minus 8 is 8. So C, both of these pairs of different atoms have 8 neutrons. Notice they are not isotopes. All right, one last thing. You may notice that when you're looking on the periodic table, that depending on the periodic table you're looking at, specifically the one in your book, that the bigger number isn't always a whole number. Well, that's because the atomic mass, which is slightly different than mass number, but the atomic mass, the AMU, is the weighted average of all the natural isotopes of that particular element. So they average however many isotopes, the percent, of the isotopes of that particular element, and they get the number. And depending on what chemistry class you're in, that number is more specific. Sometimes it's 2 decimal places, sometimes it's only 1, sometimes it's like 4 places out. So let's look at our very last slide here to show you that, for example, some different isotopes of lithium. Right, here's lithium with 3 protons, and in this case we have 3 neutrons for lithium-6, and for lithium-7 we have 4 neutrons. Well, if you average all the 2 different isotopes of lithium together, the average of all of those that appear on the Earth is 6.941. Well, the most prevalent isotope is going to be isotope 7. Why? Because this 6.9 is really close. So, in other words, don't get hung up on all the little decimal places afterwards. For this class, you're going to, for the most part, use the whole number later on for our math. If it's really close or in the middle, then we'll go ahead and use this. But there we go. Hopefully that helps you understand isotopes.